Alcohols will not be showing this reaction, only phenols will be showing this reaction. Both phenol and phenoxide ion are stabilized by the following resonance structure. So phenols consist of two parts, an aryl group and a hydroxyl group. The solubility of phenols in water is due to the ability to form hydrogen bonds with water molecules. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry. So today I am back with session 6 of the chapter Alcohols, Phenols and Ethers. So in the last session we discussed what are phenols, right? We begin with the introduction of phenols and then we studied about the classification of phenols, which was quite similar with that of alcohols, right? As well as the nomenclature of phenols and the different methods of preparation of phenol. So in today's session, we are going to discuss the physical properties and chemical properties of phenols. So first, let us begin with the physical properties of phenols. So phenols consist of two parts, an aryl group and a hydroxyl group. So in case of alcohol, it was an alkyl group and a hydroxyl group. Here it is an aryl group and a hydroxyl group. Aryl group means a aromatic ring, right? Aryl group, and then you have the hydroxyl group. Okay, so that is the two parts, and on this you can have other substituents as well. The properties of phenols are due to, of course, the OH group. The hydroxyl group, due to the presence of that, they obtain their properties. So the first one is boiling point. In phenols, the hydrogen atom of OH group is bonded to an electronegative oxygen atom. Therefore, it is capable of forming intermolecular hydrogen bonding. So likewise, we have studied already in alcohols also, because the OH bond in alcohols as well as phenol, this is a polar bond, because considering oxygen and hydrogen, oxygen is more electronegative and hydrogen is less electronegative. So the shared pair of electrons will be attracted more towards the oxygen. So it is getting a partial negative charge. Because of this charge separation, what happens? There the bond will be a polar bond, and hence because of that it will be able to form hydrogen bonds, right? Okay, so the hydrogen bonds in phenols is being shown here. As you can see, this is one molecule of phenol, OH, and you have the benzene ring. So of course, because of this electronegativity difference, oxygen will be partially negatively charged, hydrogen will be partial positive. Here also partial positive, partial negative, partially positive, partial negative. So as you can see, this is negative and positive. So there will be a bond formed between the oxygen of one phenol and hydrogen of another phenol. So this is three different molecules which are forming a intermolecular hydrogen bond, right? So because one extra bond other than the bonds which is already present, there is an intermolecular hydrogen bond also present. So of course, because of that, the boiling point will be more compared to the other hydrocarbons who is having comparable masses, right? So hence phenols have higher boiling points than the corresponding other classes of compounds like hydrocarbons, ethers and haloalkanes or arenes of comparable molecular mass. So the same thing we have discussed in alcohols also. There also hydrogen bonds are present. Here also hydrogen bonds are present. Because of that, if we are considering other compounds having comparable mass, phenols will be having more boiling point because of the presence of hydrogen bonds, right? Now what about solubility? Even this we have discussed. Because of the presence of hydrogen bond, that is, because phenols is able to form intermolecular hydrogen bonds with water, of course it is soluble in water, right? So the solubility of phenols in water is due to the ability to form hydrogen bonds with water molecules. The solubility decreases with increase in size of hydrophobic part. So as the aryl group becomes bigger and bigger, what happens? Yes, the solubility becomes lesser and lesser. Why? Because that aryl part is hydrophobic in nature. It doesn't have attraction towards water. So because of that, when the aryl group becomes bigger and bigger, the solubility becomes less, but it is soluble in water because of the presence of hydrogen bond. So this is C6H5, which is the benzyl group, right? So on benzene you have OH, that is what is shown here. The positive of hydrogen atom in one molecule of phenol is having a bond or is forming a bond with water molecule. Oxygen is having negative charge. So there is a bond you can see here. So this pink dotted line represents the intermolecular hydrogen bond which it is forming with water. So this is why phenols are soluble, right? Now, chemical properties of phenols. So those were the physical properties that you have to remember, and the same case goes with the branching and increasing number of carbon atoms. That means if more and more carbon atoms are included, of course the boiling point will increase, and if the branching increases, the surface area will decrease. Because of that, the boiling point will decrease. Okay. Now, chemical properties of phenols are mainly due to the presence of, again, the OH group. The presence of aromatic benzene ring provides some characteristic chemical reactions for phenol. So again, like we have discussed in the case of alcohol, here also we are going to classify it into two and we are going to discuss. First one is reactions involving oxygen hydrogen bond breakage, that is OH bond will be broken. Okay, fine. Next one is reactions involving cleavage of carbon oxygen bond. So for example, let us take phenol. Okay, so you have your carbon here, right, and oxygen here, this bond breakage. Based on that also we have a set of reactions. So first let us begin with reactions involving cleavage of oxygen hydrogen bond. So the first one is acidity of phenols. Okay, acidity of alcohols also we have studied. So same way, phenols are also acidic in nature because it is able to form phenoxide ion and release an H plus. Okay, so if it is able to release H plus means it's a Bronsted acid, it is able to donate H plus ions, hence it is acidic, right? So the first reaction under this we are going to study is reaction with metals. So phenols reacts with highly electropositive alkali metals such as sodium, potassium, etc. to yield corresponding alkoxide with liberation of hydrogen. Okay, so we have taken 2 moles of what? The phenol, and it is made to react with sodium. So generally highly electropositive metals are taken like sodium, potassium, which belongs to the first group. So what you will get? You will be getting the sodium phenoxide of this. Okay, so that means this is phenol which will release its H plus and form phenoxide ion, and H plus will be released. So this phenoxide ion, because we are using sodium, what will happen? It will be sodium phenoxide which is formed, and as I told you, H plus will be released. We are taking 2 moles, so because of that 2 of this hydrogen will be removed, so hydrogen gas will be liberated. I hope it is clear. Next one is reaction with alkali. If it is reacting with sodium, we are going to get hydrogen gases released and sodium phenoxide will be formed. Now phenols reacts with aqueous sodium hydroxide to form sodium phenoxide. The same will be formed here as well, but alcohols are neutral due to this reaction. Alcohols will not be showing this reaction, only phenols will be showing this reaction. Again, phenol we are taking, sodium hydroxide we are taking. So what happens here? Hydrogen from this and OH from this will be removed as water. Okay, will be removed as water. Now what happens is sodium will be attached to the oxygen and you will get sodium phenoxide. I hope it is clear. The above reactions show that phenols are of course acidic in nature. In fact, phenols are Bronsted acid, that is they can donate a proton to a strong base. So we are taking a strong base here. It is able to donate its H plus so that it is forming water, right? So I hope it is clear. So now, as discussed, acidity of phenols. Phenols is slightly acidic in nature. It dissociates partially in water to give phenoxide ion and a proton. So this is phenol. In water, it dissociates into form phenoxide ion and this H plus will be released, right? So that is why it is an acid. Okay, it's slightly acidic. Okay, now both phenol and phenoxide ion are stabilized by the following resonance structure. So this is your phenol and this is your phenoxide ion after H plus is being released. So now the resonance structure of both phenol and phenoxide ion is shown here, right? So first let us understand the resonating structure of phenol. So as you can see here, OH on benzene, and you can see on the oxygen it will have two lone pair of electrons, right? So the lone pair of electrons out of the two, one will be shifted here, and what happens, this double bond will be shifted here to become a charge, right? So what happens, the oxygen is releasing its electrons, means oxygen is going to get a positive charge, right? So that is what is shown here, and of course the electron is moving here, means it will become a double bond. So the double bond here, this bond is become charge, which is shown here, right? The next structure, this charge will become a bond here, and this bond is going to be a charge here. So the charge is present here, then the bond is here, right? And the next one, the charge is going to be bond here, and the bond will become a charge here. So the charge is shown here, bond is shown here. Again, the charge is going to be shifted here, and this double bond will be shifted back, so that again the positive charge in the oxygen will be gone. So this is the resonating structure of your phenol, okay? But moving on to the resonating structure of phenoxide ion. Phenoxide ion means after the removal of H+. So phenoxide ion, what is happening here? Already it is O-, right? Okay, so you have, that is why it is shown 3 lone pairs here, because of the presence of O-. As you can see here, already one more minus is there. It is already having 2 lone pairs also. So now what happens? This electrons will be shifted here and becomes a double bond. The bond will shift here and become a charge. Now charge shifts here and the bond shifts here to become charge. So again you will get the structure. Now the charge becomes bond, bond becomes charge, which is shown here. Now in the last part, what happens? Last resonating structure, the charge becomes a bond here, and this double bond is shifted back, and you will get the phenoxide ion, which was in the beginning itself. Now these are the resonating structures of phenol and phenoxide ion. Now when we are comparing these two, which one is going to be more stable? The more stable one is the phenoxide ion, because it is not having any charge separation. That means in the ortho and para positions, that is, this is 2 ortho positions, and the para positions you have the negative charge, but on the oxygen atom you are not having any positive charge here. But considering phenol, what happens once the resonating structure is so in case of phenol, once the resonance is taking place, you are getting a positive charge on the oxygen, right? So there is a charge separation, positive charge on the oxygen, and on ortho para positions you are having a negative charge. So because of this charge separation, phenol will be less stable. Considering phenoxide ion, you are not having a positive charge on the oxygen, only you have negative charge in ortho and para position. That is why phenoxide ion is more stable than phenol. So I hope the reason is also clear for you, right? Now we are going to study the effect of substituents on acidity of phenol. So we already studied the acidity of phenols, how it is happening, and comparing between phenoxide ion and phenol. Now apart from the hydroxyl group, if any other substituents are present, what is going to happen to the acidity of phenol is what we are going to discuss. So if electron donating groups are present, what will happen to the acidity of phenol? Electron donating groups like alkyl groups, methyl groups, increase the electron density on oxygen of phenoxide ion, and the stability of phenoxide ion will decrease. Hence acidic strength decreases. Therefore cresols are less acidic than phenol. So even this we have studied in alcohols as well, right? So when you are having electron donating group, electron donating means like alkyl group which is ready to give its electron. So what happens when it is donating its electron? The oxygen atom in the hydroxyl group, okay, oxygen atom in the hydroxyl group will be getting more electrons, and it will become more electron rich. So when it is becoming more electron rich, the polarity between oxygen and hydrogen will start reducing. Because of that, what happens is the stability of the phenoxide ion will be decreasing. Because of the stability decreases, what happens? The acidic character also of the phenoxide ion decreases. That is why cresols are less acidic than phenol. So what was cresol? We have discussed this already, right? So cresol is OH will be there as well as CH3, right? Okay, so this is ortho cresol, right? On the ortho position you have the methyl group. So this is ortho cresol. So because of the presence of this methyl group which is ready to donate its electron, the electron density in oxygen increases and the stability of phenoxide ion decreases. Now, if you are using electron withdrawing groups, what happens? Electron withdrawing groups like nitro group decreases the electron density on oxygen of phenoxide ion and stability of phenoxide ion will increase. Hence, acidic strength increases. Therefore, nitrophenols are more acidic than phenol. This effect is more pronounced when such a group is present at ortho and para position. It is due to the effective delocalization of negative charge in phenoxide ion. As the number of nitro groups increases on phenol, acidic strength of phenol also increases. So, when electron withdrawing groups are present, electron withdrawing groups are present means they are taking up electrons from the benzene ring. So, for example, nitrophenol if we are considering. So, you have your hydroxyl group and nitro also. So, this is 2 nitrophenol. On the second carbon atom, you have the nitro group, right? So, 2 nitrophenol if we are considering, it is going to be more acidic than phenol. That is without the nitro group, it is going to be more acidic than phenol because of the presence of an electron withdrawing group. Because when the electrons are being withdrawn, what will happen to the oxygen? The electron density in the oxygen will decrease. Because of the stability, because of that, the stability of the phenoxide ion will increase, and because of that, the acidity will also increase. So, now in this case, only one nitro group is there. Now, if I am adding one more nitro group, what happens? The acidity will become even more because 2 groups are there which is going to take up the electrons. Now, in the para position also, if nitro group is there, what happens again? The acidity will increase. More the electron withdrawing groups, more will be the acidity. So, when we are comparing cresols, phenols and nitrophenols, cresols will have the least acidity, then phenols, then nitrophenols. Okay, that is, this is your cresol and this is phenol and this is nitrophenol. So, if you are considering these 3, this is having highest acidity because nitro group is electron withdrawing and phenol, there is no other substituents here, and considering cresol, what happens? Alkyl group is electron donating, so it makes it less acidic, right? So, this order is also very important to remember, right? So, various compounds will be given to you and will be asked to write in the decreasing or increasing order of the acidity. So, what you have to check is whether the substituent present there is an electron withdrawing group or an electron donating group. Okay, if it is an electron donating group, the acidity will decrease. If it is an electron withdrawing group, the acidity will increase, right? So, in the next session, we are going to study the next set of reactions which involves the breakage of carbon-oxygen bond, right? So, that is the first one we are going to study is esterification of phenols. So, I hope the concepts that I have covered in this session is clear for you. So, that's all for today. Thank you.